All right, so for my explanations, I decided to use Jupyter, a online platform where you can essentially create lessons with programming and immediately run the code. As you can see here, I could run this code immediately. And so I think that this has a benefit of making the lesson more interactive because the students could themselves be able to uh, interact with the code that they're learning about. As a disclaimer, I use ChatGPT to help structure the following lessons and consider additional ideas for its improvement. So with that in mind, let's get going. All right, so the first thing that you asked of me was to explain the difference between object-oriented programming and procedural programming. So the main difference, as far as I understood it, was that object-oriented programming centers around classes, meaning that if you have, if you need to implement a function which allows a user to deposit money into their bank account or withdraw it or get their balance, then an object-oriented programming paradigm will first put the whole bank account into one class and then add methods to it. Whereas a functional approach or a procedural programming approach will not include classes, and it will mainly center around functions which are not grouped in any particular way. So as you can see, there is no group here, whereas there is a group here. And so, of course, in this case, when I demonstrate, the outcome is the same because if you deposit $100 or whatever and withdraw 50, then the balance will be 50. And that's the same here. So this is the same way to implement these functions, but it just looks different. And in some cases, it can be more convenient to use one over the other. So I have a bit of a challenge question for you. When do you think it's preferable to use procedural programming and when to use object-oriented programming? Well, in this case, the answer will be when you're writing functions for smaller, less complex tasks. Because as you can see here, it seems quite neat, quite clean to just show two functions and then you can run them right away. But what if you have 100 functions like that? What if you have a lot of variables that you need to store for a particular user? Well, in that case, using something like a class may be more beneficial as you're able to structure it better. And when you look at that person's code, you immediately know what you can do. There are additional benefits to it, which we'll discuss right now. And these are encapsulation, abstraction, inheritance, and polymorphism. All right. So the four core rules of object-oriented programming are the first one is encapsulation. And the way by which I'd explain it is through this class, this car class, which I made for you. And essentially, for a broad overview, encapsulation refers to bundling data, so bundling attributes together, and methods into a single unit or class. This is kind of what we mentioned already in the idea of object-oriented programming. This is essentially what it is. So as you can see, the class is car, and then you initiate this class. This is how you initiated it in practice. And of course, you can get the methods. So essentially, encapsulation means you put things together in a class. And this is what we've done here. And as you can see, if we get info for this little object that we created, we get the output Toyota Corolla, which is what's intended. All right, so then the next concept is abstraction. Abstraction involves hiding the complex implementation details of a class and exposing only what is necessary. So again, I continue with the example of a car, and here we don't have to run this whole function. We don't have to recreate this function for these different cars because I have a Honda Civic, I have a Tesla Model Y. However, I didn't need to recreate this start engine method for both of these cars separately. So I didn't need to write def start engine for Tesla and then repeat everything that I wrote here, it's already created. And essentially, abstraction means that we've put it in a class and therefore we can reuse it in different cases. So that's what it means to reduce complexity because we can reuse different details and we don't have to try and understand what this method does precisely. We can just run start engine and it does it for us. So that's abstraction. Then inheritance allows a new class to inherit attributes and methods from an existing class. So this is a continuation of what we've been talking about. When I have a vehicle, I can also create different variations of this class. So as you can see, I passed the vehicle class here, and as a result, I could make a car. This is an important part in understanding what inheritance is, because if you know what this does, then you know what inheritance does, and you know what it's useful for. So let me explain that really quickly. Here, we run super, which essentially what it does is it runs this class in the same way that we ran it here, right? So we ran it here, and this initialized it. We do the same thing here, here, and as a result, when we run car here, it goes into the car class, it initializes it, and so it adds doors, but it also initializes the vehicle, meaning that both of these classes initialize. Since this is the parent class, um, its attributes are included in the car. And so then we have the model, we have the make, though we didn't write it here. As you can see, we didn't actually write out the properties make or model, but we're able to access them, which I'll show you right now. My car, make. All right, let's see if that works. So we already showed that. See? Yeah, beautiful. So essentially, we were able to leverage the parent class, and the parent class, the child class inherited the values of the parent. And as a result, we were able to get its values, though we were only calling a child. So it's as though these classes were combined together. If you pass it here, you have a relationship between them. Okay, so that's inheritance for you. Now, the last part that's important to mention is polymorphism. Polymorphism is useful in programming as it allows objects to be treated as instances of their parent class, even if they behave differently. This is useful when a function can operate on objects of different classes, but the specific behavior of the objects may vary. So essentially, when I mentioned inheritance is absorbing the values, the car absorbed the values of the vehicle, it took it into itself. The same is true of polymorphism, but we can extend this idea to multiple classes. So for example, we have a shape here, and then we can include this shape in the square or in the circle. And mm, despite being different classes, they both inherit the shape class. Yeah. So they inherited the shape class. And also, another part of it is though they have the same method, the same area method, because the area method is different, as you can see, to get the area of a square, you multiply it side by side. That's simple math. You probably know that already. Whereas in a circle, you do pi times radius, so radius square, essentially. That means that if we run the area, you can get different values, though you had the same inputs. So this is important to reiterate. You can have different methods which have the same name, even though they share the same class. So that's what polymorphism focuses on as well. It's the ability to have different, mm, they morph into different, they have different meanings depending on what class you use. So area here has a different meaning than here. And of course, it results in a different outcome. All right, so I skipped inheritance and polymorphism because I thought that I explained them quite well in the 4 core rules of object-oriented programming. So let me get straight into algorithms and complexity, bubble sort and merge sort. That's a fun topic, and I'd love to share more about it. All right, so bubble sort and merge sort are simply different ways of sorting a list. So imagine we have a list like this, and our goal is to make the smallest value in ascending order, um, order it essentially, right? So 11, it'd be 11, 12, 22, 25, 34, 64, 90. However, now it's pretty much the very opposite of that, meaning that we either have to create some sort method or use Python's traditional sort methods. In this case, we're going to create it because we want to explain how they actually function. Yeah. So bubble sort, it's an incredibly simple and intuitive way to sort a list, whereas merge sort is somewhat more complicated. But before I explain what they are and what they do, I would first just like to exemplify them by illustrating the steps it takes to sort a list using them, right? So we're going to run this function for you. So as you can see, it's at the beginning, the list is essentially ordered in descending order with 90 at the beginning, but then slowly it moves, it bubbles up. That's why the term bubble sort, up to the very top. And then it remains at the top. The same with 64. As you can see, after 90 is sorted, 64 is going to start moving out here, and then it's going to remain for the remainder of the iterations. The same with 34, and with all the other values, either just moving, bubbling up to the top or the bottom, depending on which direction you want to sort it in. Yeah, so bubble sort took 21 iterations, and it sorted our list. Beautiful. Now merge sort, a bit different way of doing the same thing. And we'll explain what the nuances, what the differences of it actually are after we show how it functions. So, as you can see, it took much fewer iterations. You can be surprised why there's just a few values here, but we'll get to that in a second. Here, it took 6 iterations rather than here 21. So you can see that we're starting to think about complexity. We're starting to think about the ability to do something in less time. As you can see here, this probably would take less time since it has fewer iterations, and generally, from my understanding, the code also takes less computing time. So now that we've established that there's a difference between um, these two different sorting methods, let's try to understand what they actually were. So bubble sort is essentially, I'll demonstrate it to you by example. 90 is, I think here would be better. So 90 is compared with 64. So the first value is compared with the next value. And then if it's bigger than it, then it moves to the um, next order, next index. So see here, 64 and 90 were flipped around. And then 90 is it bigger than 34? Of course. So then it's moved to the next index. And then the same is true, and it continues on and on and on until it's at the end. Of course, yeah, yeah. So that's what it does. 64, is it bigger than 34? Yes. Is 64 bigger than 25? Of course. Is 64 bigger than 12? And so on and so forth, right? And so that's what it does for each individual value until you get to the very end of this list. The problem with bubble sort is that we're only changing one value at a time, and we're going through all these redundant values. So for example, when this value is already sorted, we have to go through all these remaining values, making sure that they're also being sorted. And this has, especially with big lists, this takes a long, long time. In a second, we're actually going to explain how long, but for now, let's stick with just knowing that it takes a long time. On the other hand, merge sort, a bit more complicated to understand, so I can appreciate if it doesn't immediately seem obvious. However, what you do is you split the list into pieces. So first you split it in half, so it would be split like so. So 90, 64, 34, 25, 12, 22, 11. And then it's split again and again until there's just two values in each little list. Then, once these little uh, lists with two values are already broken down, then each of them is flipped such that they're um, they're put into order. I think an illustration here would be quite useful. So as you can see, I mentioned that we split the list into two pieces, yeah, and then we split it again until we reach a pair of two values. If there's an odd number of values, then every now and again you'll see one, but in this case there's an even, so there's two. Yeah, so 7 and 3, 2, 16, 24, 4, 11, 9. The same was happening here. Then, once you have them broken down, then you flip around in order each of the values such that in this case, the smaller value is here and this bigger value is here. So see, this is the outcome. 7, 3, and this little operation changed to 3, 7. 2, 16 in this case doesn't change. 24 and 4 does flip around, and 9 and 11 stays the same. And so then we have you can say, imagine that the whole list is slowly sorting itself simultaneously across different pieces. And then we do the same thing again, just this time with more elements. So we combine the elements together, and see that's why there were more elements here than here. Um, and then make sure that they're in order. So you see 3 and 7, 2 and 16, that would end up as 2, 3, 7, 16, right? It's more in order now than it was. Okay. 4, 24, 9, 11 becomes 4, 9, 11, and 24. Again, the whole list is becoming more and more ordered simultaneously. And the advantage of this is that once the list is essentially mostly sorted, it's actually quite simple to then finalize the sorting process. So unlike the first sorting method, which we used, which was bubble sort, where each time the whole list is checked and each value is checked against the whole other piece of the list. In merge sort, you only focus on a few values. And as a result, because you focus on a few values and you make sure to change each of them before you go on to the next step, so combining them and sorting that list, the list is becoming ordered and the ordering is building on itself, right? Okay, so then finally, step 4 is merging and sorting all the sublists until you merge the full list and it's all in order. And so that's essentially what we got here. Okay? The sorted array was completely sorted, and it only did so in 6 iterations. Now, we're not going to get into the code of this for now, because it's quite complicated. It looks complicated. It's not complicated. Essentially, we explained the functionality of it already, but before we get into how it looks like, we first have to learn a few functions of Python. All right. So I think I've explained that quite effectively. If you have any questions, then do let me know, and I'd be happy to field them.